Do you ever feel the need for a way to switch off lights without moving? Do you wonder if you had left the lights and fans in your home on? Have you ever wondered how the people who are in a wheelchair operate the lights and fans? To add convenience and accessibility in your life, we present to you the Smart Switch, the Bluetooth controlled switchboard.
As you can see, the problems in the similar existing models is that they are very unreliable because of the electronic components involved, and in order to eliminate these issues, we have tried to make a product which can be controlled both via Bluetooth enabled device and mechanically via switches. First of all, we will connect the Bluetooth module with device. As you can see, the LED has started blinking twice a second instead of being rapidly. First we'll test that whether this switch is mechanically working. So as you can see, the voltage here is 2.7 volts, and when I switch this on, it becomes 220 volts because it's connected to the main power supply. Then we'll see this LED lights are also working by mechanical switches. Now we will send signal to our app. So as you can see, the reading here has changed because we switched it by our app. We can see that this is still working, and now this LED is by this signal. And as you can see, these all will still work. First we made a model of board for laser cutting, which was to be the top face of the model. Then we made assembly files. Here are the assembly files and here are the electronic components. Not all the components are shown here, and we can see the presentation here. So our model is assembled basically like this.
Coming to the electronics part, we first created a very simple prototype by connecting an HC05 Bluetooth module to the Arduino. We successfully controlled the Arduino's onboard LED using our phones via the Bluetooth module.
Talk to me, girl, I got the right to say. You wanna stay with me, you dance all day. I got the people now, I show my moves.
Our first step was to design a circuit which enables both manual and electronic remote control. We used a circuit similar to staircase wiring, which controls one device from two locations. We used a two-way switch and a relay to toggle the circuit. The relay is controlled by an Arduino, which takes signals from an HC05 Bluetooth module that is linked to a smartphone. As we can see from the circuit diagram, toggling either one of the switch or the relay switches the state of the system and the device turns on or off.
First of all, there was a lot of noise in HC05 to mobile communication. because of HC05 being a prototype model which will not be used in industrial manufacturing.
We had given a supply of 3.3 volts to the HC05 Bluetooth module from the Arduino itself. In this configuration, however, the connection with the smartphone was erratic and would disconnect randomly. We tried to explore various other options of powering the HC05 Bluetooth module, like creating a voltage divider circuit from the DC supply of the adapter and also creating a battery pack from 1.5 volt riser. The module was receiving its rated voltage and current, but still the connection was erratic. In the end, we decided to give it a slightly larger voltage of 5 volts, and the problem was thus solved. The problem that we faced while making this project was the proper placement of all the electronic components inside the box. We had to do it in such a way that it would lead to very less intertwining of wires while still ensuring a robust fitting of all the components inside the box.
Through this activity, we learned about teamwork, increased our problem solving abilities, and learned various engineering principles.